How are you guys? This is chemistry time, and today we are going to look at chemical formulas. Okay, so we are going to look at the definition for a chemical formula. We are going to look at examples for chemical formulas. Then we need also to know how to formulate these chemical formulas. So I'm going to teach you how you can formulate your own formula. Okay. Now let us start. We are going to start with a definition for a chemical formula. What is a chemical formula? That's the question. Now a chemical formula is defined as a formula that is formed by combining two or more elements with respect to their what? Valences. So which means that if you want to come up with a chemical formula, you need to have a number of things. One, you need to have at least one element. So you need to have elements. Okay, so we are saying you need to have at least one element for you to come up with a chemical formula. Okay. Then apart from this, you need to have what we call valences. Valences. Now these valences, they are the valences of these two elements that you have, or the elements that you want to formulate the chemical formula of. Okay. Now, let me give you an example. For example, maybe you have lithium. Okay, that is a chemical symbol. Now, if you have lithium, then you have oxygen. Okay, lithium is an element. Also, oxygen is another element. Now, you need to know the valence for lithium. Now, lithium is in group 1 of the periodic table, and all group 1 elements, they possess, they have a valence of 1. They have a valence of 1. So which means that lithium, it has a valence of 1, and oxygen, it is in group 6, which means it needs to gain it needs to gain 2 electrons for it to become stable. Hence, that number of electrons that it needs to gain for it to become stable, it is called a valence. So we have agreed that it has a valence of 2. Then what do? You bring this Li, which is lithium, down, and this oxygen, you bring it down. Make sure that the ratio between these two elements, it is in its simplest form. Okay. Now, after you notice that, you need to cross multiply. Okay. This valence goes at the bottom of that element, and this one goes at the bottom of that element, which means that we are going to have a chemical formula for lithium oxide as follows. Lithium, it will have a 2 at the bottom, and oxygen, it will have a 1 at the bottom, and we don't show if it is 1. So which means that the chemical formula for lithium oxide, it is Li2 oxygen, or O. Okay, so that is a chemical formula for that particular compound called lithium oxide. Okay, so we are done with that part there, where I was showing you, where I was trying to define what a chemical formula is. Okay, now let us look at examples. We are saying that examples of chemical formulas, we have sodium oxide, we have calcium chloride, we have copper oxide, we have water, which is H2O, then we have carbon dioxide, okay, which is CO2, then we have we have KCl, which is calcium chloride. Now, someone else will ask, okay, where did you get all those chemical formulas? Now, I'm going to show you where each of these chemical formulas are taken from, or where we have derived them from. Okay, now these chemical formulas, for example 1, is taken from the same way we have obtained lithium oxide here. Okay, lithium oxide here. So which means that we need to notice that the elements that they are reacting here are the elements sodium and oxygen. So I'll have sodium and I'll have also oxygen. Now sodium, it is in group 1, so it has 1 valence. I'll put a 1 there. Okay, then oxygen, we know now that it is in group 6, so it has a valence 2. Now I'll bring down sodium and oxygen there. Then I'll swap the valences, which means this valence, it will go at the bottom there, and this one at the bottom there. Okay, so which means that now we are going to have sodium with a 2 down, then oxygen with a 1, and that one we don't show, please. Okay, so which means that this is now a formula for sodium oxide. Then apart from this, we have now the second one, which is calcium chloride. So calcium chloride, it is a compound which is made up of calcium and chlorine. Okay, so we have chlorine this side, we have calcium there. So calcium, it is in group 2, so it has a valence 2. Then we have chlorine, which is in group 7. It needs to gain 1 electron for it to become stable. So that number of electrons that it needs to gain for it to be stable, it is equal to the valence. So the valence is 1. So now I'll bring calcium down and chlorine down. Then I'll swap also the valences like that. So which means 1 goes there, which we don't show. It will become calcium. Then oxygen goes, this 2 goes down to calcium there. To chlorine there. So we have a 2 there. So which means the chemical formula for calcium chloride, it is CaCl2. Okay, then let us also go for the third one, which is copper oxide. Now copper oxide, it is a compound which is formed between copper and oxygen. Now we need to understand that copper, it is a transition metal, and all transition metal at a certain degree, they are considered to have a valence 2. Okay, to have a valence 2. So we know that copper, it has a valence 2 because it is a transition metal. Then apart from that, we have oxygen there, and we know now the valence for oxygen, it is a 2. Now just like I've told you earlier on, to say if the valences, they are not in, you need to make sure that the valences are in their simplest form. Now in this case, the valences, they are not in their simplest form. The ratio of the valences. Okay, we know to say it is to what? To 2. Okay, we have 2 to 2 there. So we need to simplify the ratio of their valences. It will be 1 to 1, because 2 into 2 is 1, 2 into 2 is 1. So which means that their valence now, it will be 1 to 1 instead of 2 to 2. You need to take notice of that. Okay, so now, which means that we have oxygen with a valence, we have copper with a valence 1, and oxygen with a valence also 1. Then we bring down copper there and oxygen down there. Then we swap the valences, which will give us calcium oxide. So which means that here now we have the chemical formula for copper oxide. Okay, we go for number 4 now. Number 4 is for water. Now water, it is a compound which is formed between hydrogen and oxygen. Okay, so we have hydrogen and oxygen. Now hydrogen, it is on top. Okay, it is on top of the periodic table. Okay, it is considered to have a valence 1. Okay, it is considered to be in group 1, also to be in group 7. Okay, the reason is simple. It is because hydrogen, it can either gain 1 electron for it to be stable, or lose 1 electron for it to be stable. Hence, it is placed up there. Okay. So we know now that the valence for hydrogen is 1, because all group 1 elements, they lose 1 electron for them to be stable. And that particular number of electrons that they lose for them to become stable, it is called the valence. Okay. Then also oxygen, it is 2, as usual. Now, we bring down hydrogen, we bring down oxygen. Then, since the valences are already in simplest form, we need to swap now the valences. So we are going to have H2, then oxygen 1. This is a chemical formula for water, or the formula for water or steam. It is also the same formula for ice. All you need to do is just to include some set symbols here, okay, to show to say it is a liquid, solid, or gas state. Okay, now apart from this, we have now we have number 5, which is carbon dioxide. Now carbon dioxide, it is made up of two elements, which is carbon as well as oxygen. Now you need to understand that we are saying that this element, this compound, it is carbon dioxide. So Dao simply means 2, which means that the carbon, it is the one which it is considered to have a valence of 2. And in this case now, okay, we consider oxygen to have a valence 1. Okay, or if you want, you increase the number of valence for carbon to 4, and for oxygen it maintains, which is 2. When you simplify, it will be 2 to 1. Okay, so now I'll blend down carbon there and oxygen there. The valence here, it is 1. Please notice there is a reason why I've said that oxygen, it has 1 this time, okay, and carbon, it has a valence 2 this time. Okay, I believe that carbon, it is in group 5 of the periodic table, so it has a valence. In normal case, it has a valence 3, but in this case, since we are talking about carbon dioxide, which means it will be considered to have a valence 2 and oxygen to have a valence 1. Then you swap, you are going to get, okay, it is oxygen that it is having a valence of 2. Then carbon, it is the one which is considered to have a valence 1. Then when we swap the valences, we have a 2 there, we have an oxygen there. Oxygen 1. Then we go for the last one, which is calcium chloride, okay, which is the 60th one. Now, calcium chloride, it is a compound formed between calcium, it is called potassium chloride, okay, potassium chloride. Now, potassium chloride, it is a compound which is formed between potassium and chlorine, okay. Now, potassium, it is in group 1 and it has a valence 1, and chlorine, it is in group 7 and it has a valence 1. Then the valences, it is a 1-to-1, which means that when we swap the valences, we are going to obtain a compound which is KCl as the compound or as a chemical formula for potassium chloride. Okay, so next time I'll be teaching you how to formulate chemical formulas between an element and a radical. Okay, see you next time.